Assalamualaikum warahmatullahi wabarakatuh, and a very good day I bid especially to the panels, Dr. Elinada binti Abdul Latif and Dr. Alice bin Muhammad Samad. My name is Hannah Jaya binti Syamuddin, and today I'm going to present to you my final year project proposal with the title of an optimization of PLA injection molding processing for product packaging by using design of experiment. In a nutshell, this project deals with the usage of polylactide or PLA as material. PLA possesses good mechanical properties, biodegradability, and renewability. PLA is the current frontrunner in replacing the traditional petropolymers. Injection molding is the lead process used in making thermoplastic product packaging. This is because of the low labor cost and also high flexibility in design. In this project, the optimization of PLA injection molding to be discovered. This SolidWorks software will be used to do the simulation of injection molding. Not only that, design of experiment (DOE) will be applied in selecting the relevant parameters, number of test runs needed, and especially in optimization of PLA injection molding. By the end of this project, the optimal parameters with good filling time and low shrinkage value will be determined. Moving on to introduction, plastic is commercially used and made from many different materials such as clay, aluminium, metals, and of course plastic. Plastic, out of all the other materials, had the most development due to the low cost of manufacturing and also for the manipulatable properties. Despite the positive improvement, the environmental impact, however, is on the negative side. For example, in Europe, 39.6% of the plastic produced were made into plastic packaging. However, only 16% of the plastic packaging were recycled to become another plastic product, while the others were dumped, incinerated, or sent to the landfills. So this is why PLA polylactide is the upfront substitute for recyclable plastic packaging. PLA is derived from renewable sources such as corn, beets, sugar, and etc. Moving on to literature review. From the first journal, Multifunctional Nanoconstructed PLA Materials for Packaging and Tissue Engineering, it is said that there is an increasing demand for biodegradable polymers to use as a substitution to the traditional petropolymers. This is because the traditional petropolymers cause environmental pollution, and so PLA exhibits several advantages in being the substitution due to its good transparency, degradation in biological environment, biocompatibility, and processability as a packaging material. Next, on the second journal, an overview of polylactide as packaging material, it said that in early economic studies show that PLA is economically feasible material to use as packaging polymer. Not only that, the medical study shows that the level of lactic acid (La) that migrates to food from the packaging container of PLA is much lower than the amount of La used in common food ingredients. PLA is being used as packaging material currently for short shelf life products such as drinking cups, container for sundaes, salad cups, overwrap, and others. In the third journal named Effect of Mold Opening on the Properties of PLA Sample Obtained by Foam Injection Molding, it is said that the injection molding processes that is simulated through computer-aided design or engineering software can simplify the process, especially in the design of the mold, such as with the cavity shape, gating points, and cooling elements. Not only that, simulation also will cut the time needed and the cost needed for injection molding. Next, on the last journal, it said that in the case of PLA injection molding, increasing the mold and cooling temperature will have a negative impact on the warpage and shrinkage. Not only that, increasing the packing pressure, however, will produce a positive impact on warpage and shrinkage, which are the two common problems that will happen in injection molding process. Next is problem statement. The other conventional petropolymers used in making plastic packaging will take up to thousands of years to decompose. This, however, is causing harm to the environment. PLA, when decomposed, it will produce lactic acid, which are commonly found in the human body, for example, for metabolism. And the decomposing of PLA will only take up 1 to 2 years. However, in the case of using PLA as material in injection molding, By increasing the mold and the cooling temperature, we have a negative impact on the shrinkage and warpage of the end product. This loophole available in the study of PLA material for using in injection molding explain the relevancy of my study in optimizing the parameters. Next, the objective of this project first is to determine the working parameter of PLA in injection molding using design of experiment. Second, to optimize the parameters of PLA injection molding within the allowable range of the material characteristic. Lastly, the simulation to be conducted should obtain the satisfied result with good filling time and low shrinkage value.
Next, for the scope and limitation of my project. First, the development of the 3D model by SolidWorks software will only by using pure PLA material without the addition of any other agents. Second, the injection molding process, the simulation, will be done through SolidWorks software. Third, the relevant parameters such as the mold temperature, melt temperature, packing pressure, packing time, and others, number of test run needed, and also for the optimization process of the PLA injection molding will be done through DOE. Last but not least, this study is done through Open Distance Learning (ODL) due to the current COVID-19 pandemic that is happening worldwide. Now, for methodology, I have prepared a full chart that is relevant to the study. Of course, first and foremost is the preparation of the 3D model, and will be done through the SolidWorks software. Not only that, the PLA material characteristic and information will be inputted manually into the SolidWorks software. After conducting the injection molding process simulation, now is for the optimization, and will be performed through RSM regression analysis. After all the analysis will be done, and after the optimization, the optimum parameters is obtained. After compare with the predicted, the optimal injection molding processing parameters will be defined. The expected results were obtained from previous studies. First, for the fill time, the fill time of a dog bone model of a PLA injection molding was 1.781 10 to the power of negative 4 seconds for minimum, whereas 2.8571 seconds for maximum. The influencing parameters in order to obtain a good filling time will be the melt temperature, mold temperature, coolant temperature, injection pressure, and also the packing pressure. Not only that, the design of the runner system is also important in order to obtain a good filling time while not jeopardizing the end product. Next is for shrinkage by volume. The volumetric shrinkage occurring on the dog bone model was 13.6146 molar percent on the thickest part of the model. The shrinkage volume of a molded plastic product is acceptable up to 20%, so this is still acceptable. The shrinkage of 1.1248 volume percent occurred on the running system, and this may affect the quality of the PLA end product. It is said that the melt temperature and mold temperature are the two influencing parameters for shrinkage. However, the optimization of PLA material for injection molding is still relevant despite of the high acceptable volumetric shrinkage, because the typical shrinkage rate for PLA is 0.3% to 0.5%. Moving on to preliminary result. For preliminary result, I have designed a dog bone following the ASTM D638 type 1 parameters, and I also imported the PLA material information into the SolidWorks software, and I did a test run of injection molding on this 3D dog bone model. So for the first test run, the fill time for this dog bone model was 5.610 to the power of negative 5 minimum and 2.8448 seconds maximum, which is still pretty similar from the expected result from the previous studies. For the shrinkage of my 3D dog bone model, however, is on the higher side, where the minimum is 5.2680 volume percent and 14.1206 volume percent for maximum. As I said before, it is still acceptable for plastic injection molded product to have a shrinkage up to 20%. However, the rate of PLA is only 0.3 up to 0.5%. So my study, the optimization of PLA injection molding, is still relevant in order to decrease the shrinkage by volume. This is the Gantt chart I made for this project, and as you can see, everything is still according to plan, only the submission is earlier on the week 13. These are the list of my references from 1st up to the 7th, and this is 8th up to the last one, the 30th. That is all for my presentation for my final year project. Thank you so much for watching, and I would like to apologize for any lacking or mistakes that I have done throughout this presentation. Thank you so much.